Hey everyone, it's Greg again. Welcome to eddc608 week 2. And our primary topics this week are the central limit theorem, and that is explained relatively well in the content. So what I want to focus on, the two other topics, are confidence intervals for the mean and confidence intervals for proportions. So we'll talk about that in a minute. Okay, what is a confidence interval for a mean? Let's say we have a population of 8th graders, and they just get done taking a spelling test. And so in that population, there's all kinds of scores ranging from 40 to 54, and there's hundreds of scores in that population. Now, you would like to know what the mean score of all those 8th graders in that population is. And of course, you can't take all the 8th graders, add them up, and divide by the number and come by the mean. So you use your first inferential statistics technique, which is called a confidence interval for a mean. And here's how it works. So let's say you take a sample of 10 of these 8th graders, you add up all their scores, you divide by 10, you get a sample mean of 42, and then you compute a sample standard deviation of 5. Now, remember the calculator we used in the first week for usable stats. You can take these sample values, the actual 10 sample values, and put them in that calculator, and it will give you the mean and standard deviation of this sample, because that's what we're working with. We are working with a sample from the population. Now, once you have that information, what you're going to do is develop a confidence interval, which is a range within which you believe that the population mean actually resides. And here's how we'll do it. Without going into the underlying mathematics of it, we're going to use the calculator graph pad, confidence interval for a mean, which is in your content. And it will allow you to compute these confidence intervals. Now, I just picked up the picture of GraphPad. Let me show you how it works. There we go. And as you can see, I have put in the calculator, I have put the there it is right there, the mean, the standard deviation, and the sample size right in the GraphPad calculator. And when I click Calculate Now, I get confidence intervals. I get 3 of them. My first confidence interval is 90%. And what it tells me is between 39.10 and 44.9 is where the actual population mean lies, and I am 90% sure of that estimate. Now, I get another interval, which is 38.42 to 45.58, and I can be 95% sure that the population mean is within that interval. And I can also get a 99% confidence interval, which tells me I'm 99% sure that the population mean lies between 36.86 and 47.14. Now, confidence intervals are discussed briefly in your book, but we've included them in the course because they're one of the most basic inferential statistics needed. You can estimate population means simply by taking samples. So we'll work a little bit with that this week. The other topic we're going to work on this week is called confidence intervals for proportions. Okay? Well, what is a confidence interval for a proportion? All right, let's say that we want to do some political sampling. And you've heard it before, out of 1,000 voters sampled, 54% of them favor a certain politician. Well, how do we know that? Well, we use what's called a confidence interval for proportion calculator. Now, let me pull that up and show you how it works. Okay, so this calculator is also referenced in your content, and here's how it works. Let's say I sample 500 people, and I find that 42% of them drive a hybrid car. Now, can I be sure that 42% of the population drives a hybrid car based on my sample of 500? Well, I can't. This is an inferential statistics technique. So I'm going to take the calculator, and I hope you have it open now, and I'm going to put 420. I'm sorry, we're going to change this to 1,000. We're going to change this to 1,000 sampled, 420 drive hybrids. Okay? And then I'm going to put total passed, or total tested, of 1,000. And I'm going to click calculate. And as you can see from the calculator's results, when you go down to what's called the walled method, then you will see that there is a 95% chance, that the true population proportion is, it can't be, we don't know for sure that it's 42%, but we do know that it is somewhere between 38.94% and 45.6%. Okay? So that tool allows us to compute a confidence interval for a proportion. So let's say we wanted to know of our 420 graduating seniors, what proportion of them took AP courses. If we took a random sample of 20 and then asked the 20 of them, did you take an AP course? Then we could make an estimate of the true proportion of students that took AP courses. And that's what a confidence interval for a proportion does. Now, we won't use that quite as much, but it's also a very important inferential statistic technique. So I would encourage you to practice with both those calculators. They're very important. Confidence intervals for means and confidence intervals for proportions. The calculator is actually called a confidence interval calculator for a completion rate. That's because it's actually, the website is basically used for medical testing. But what it's essentially saying is, if you gave 1,000 people a certain medicine, what proportion of them would have benefited from it? So it's still a proportion calculator. So it'll work for our purposes. And these calculators have been tested repeatedly, and they work. They're good calculators. So practice with them, and if you have any questions, let us know, and have a good day.